Hi, welcome to the video solution for physics past paper. This is Edexcel IAL Physics Unit 1, January 2015. Question number 1. A plane is traveling horizontally at a constant speed. It releases a package of supplies when in the position shown. Which of the following shows the path of the package after release? This question is in fact uh, describing the motion of a projectile. So when the package is released, due to Newton's first law, the package would have the same speed as that of the plane. That means for a very short interval, as soon as the package is released, the package would be moving horizontally with the velocity of the plane. But at the same time, weight starts acting downward. So the package is going to accelerate downward. So this path of the package would be a parabolic path. That means it must be c. It cannot go directly down because it has a horizontal velocity. It cannot follow the path b because it's a straight line, and path d is a longer horizontal distance. So it's a parabolic path. So generally what happens when you release horizontally some object, it moves something like this. So your option is C. Question number 2. A marble is dropped from the roof of the building and takes 3.2 seconds to reach the ground. The approximate height of the building is, you need to find the height, and a marble is dropped. Dropped means initial velocity of the marble was 0. So this is a building. This is the height, and you can assume this is a marble. You dropped it. So initial velocity is 0. Time taken by the marble is 3.2. So it's a vertical motion and accelerated motion. So you use S is equal to ut plus half at square, and u is 0, and acceleration would be taken as 9.81 meter second minus 2 because the marble is coming down. So your S is equal to half of 9.81 times t square, 3.2 square. If you solve this, your distance or height will be 50.22 meter. If you round it off, your option is C. Three, a box of weight 150 Newton is placed on an inclined plane. The component of the box is weight acting along a plane is W dash. This is component of the weight acting along the plane, W dash. So W dash in Newton is given by. So if you see, this is the inclined plane, and you can say that this is the normal reaction, and this is the weight W. And you can resolve W into its component. So you see that this is perpendicular component, this one is a parallel component. If this angle is 15, then in this triangle, this angle must be 15. So this is 150 sine 15, and in fact this is your W dash. This is the component of the weight along the plane. You see, this is the parallel to the plane, which is W dash. So your W dash value would be 150 sine 15. Option is D. 4. In which of the following is a vector fully described? A car travels north, it has a direction but no magnitude. A crane moves a load 20 meter east. Okay. A train travels at the rate of 35 meters per second. Again, magnitude given, no direction. A lift moves upward with a kinetic energy of 2.5. So direction is given, but in fact they are talking about kinetic energy, and energy is not a vector, so it's a scalar quantity. So you cannot have you ignore option D, option A, option C is gone, and clearly if you see the crane moves a load of 20 meter, this is the distance traveled by the train toward some given direction, which is east. So direction is there, 20 meters is there, so option is B. Five, a ball is thrown vertically upward with a velocity of 3 meters per second. At the maximum height, the acceleration of the ball is. A ball is thrown vertically upward. If you recall, some object thrown either vertically or maybe dropped from some height, or maybe kicked, something like this. So all these cases are projectile. These two are vertical projectile and this is two-dimensional projectile. And all these particles are moving under gravitational force. Under gravitational force. So if an object moves only under gravitational force or a gravity, so for throughout during the whole motion, acceleration remains minus 9.8, always negative. No matter it is moving up or down, or it is at the bottom or it is at the top, acceleration always remains minus 9.8. And the reason is, for the whole motion, weight of the particle always acts downward, due to which acceleration always acts downward towards the negative y-axis. That's why it has negative. So your option is D. 6. A ball is thrown vertically upward. It reaches a maximum height, moves downwards, and is caught by the thrower at the time t. Which of the following is kinetic energy time graph for the ball? Again, it's a free fall motion. You have a ground and you throw a ball in upward direction. When you throw a ball in upward direction, so you give some kinetic energy. So at the bottom, the kinetic energy is maximum. And as the ball keeps moving up, its velocity keeps decreasing, you know that. So if velocity is decreasing, that means kinetic energy is also decreasing. And when the ball reaches at some maximum height, then the velocity becomes zero, so the kinetic energy, okay, and when the ball starts coming down, so velocity starts increasing, so the kinetic energy, and then when it reaches at the ground, so it has again a maximum kinetic energy. So in the first graph, option A, they are showing that as time is passing, kinetic energy is decreasing, but it is not showing the increasing part. So you cannot have option A. Option C, kinetic energy is increasing, but there's no relation. D. B, as time is passing, so this first half of the curve is showing that the kinetic energy is decreasing. This is the time when the ball reaches at the top. and then it starts coming down. So ball is coming down, but the kinetic energy is increasing. So your option is B. 7. A material that is able to undergo plastic deformation uh, under compression is said to be. So under compression, plastic deformation, this is the property of malleable material. So option is D. 8. A girl of mass 30 kg and a boy of mass 45 kg sit on a frictionless floor holding the two ends of the rope. The boy pulls on the rope. The girl moves towards the boy with an initial acceleration of 3 meters per second square. The boy, option A, moves towards the girl with an initial acceleration of greater than 3. The boy moves towards the girl with an acceleration of less than 3. The move toward the girl with an acceleration of 3 remains stationary. The most important point to understand in this situation is there are 2 points in fact. One is masses of girl and the boy, and more important the masses is that they are talking about frictionless surface. So meaning if this is the frictionless floor, this is assume this is a girl and this is a boy. Boy has a higher mass and both are holding end of the rope. So the boy is pulling the rope and the girl moves towards the boy. So that means boy is pulling the girl, due to which girl moves towards the boy. Then according to Newton's third law, girl apply force on the rope or on the boy with the same magnitude, and so both forces are equal. So according to F is equal to ma. If you see acceleration depends on two factors, F over m. For both cases, for girl and the boy, applied force is same, but mass of the boy is greater than the girl. That means acceleration is inversely proportional to the mass. So if girl is accelerating toward the boy with an acceleration of 3 meters per second square and the mass of the girl is 30 kg, but mass of the boy is 45 greater, so acceleration of the boy should be less than the girl and the boy will be moving toward the girl with the less acceleration than the girl has. So if you see move towards the girl with an initial acceleration of less than 3. So of course mass is greater, mass of the boy is greater, that's why acceleration cannot be the greater and they cannot have a same acceleration because masses are different and cannot. So your option is of course B. 9. A thin wire of uniform cross-sectional area is stretched by an increasing force. The corresponding stress-strain graph is shown. Okay, point W, X, Y, and Z. W, X, Y, and Z are shown on the graph. Select the row of the table that correctly identifies the yield point, limit of proportionality, and the elastic limit. Remember, the limit of proportionality always comes first, and then elastic limit, and finally the yield point. So yield point is your Z, limit of proportionality is yield point is Z, and limit of proportionality is W, okay, and the elastic limit is what was it? W, X, and Y and Z. Elastic limit is Y, because if you see till Y, the curve, the graph is not not a straight line, but it has shown a very little bend, and this is the behavior of elastic limit. So your option is B, because after Z it shows a large plastic deformation. So before yield point you have elastic limit. A force is applied across the ends of a spring, and the following force extension graph is drawn. The 3 points PQR are marked on the graph. At point Q, the applied force is 0. In the table below, the spring is represented using diagram drawn to scale. The spring at Q is represented by this shape. That means Q, if you see the Q, where the extension is 0, so that means applied force is 0. So this is the original shape at Q. Select the row of the table that correctly represent the length of the spring at the position P, Q, and R. So if you see R, for R you have a positive force. That means you have extension. So a spring is being extended. And for P, you have a negative force in the sense of opposite direction. So for P, a spring is being compressed. So for P, you have a compression. For R, you have extension, and Q is a unchanged shape. So for the second column, Q has the same shape. So for P, you have a compression, and for R, you have extension. So of course, P is compression and R is extension. You also have a P here, which is compression, which is correct description of P. But if you see, R is also showing no extension. So that means you cannot choose D. Even if you see in option B, R is showing extension, which is correct description of R, but P is showing no extension, which is wrong. So option is A. So a manufacturer of a spring balance needs to select a spring that produces an extension of 0.8 centimeter for each 100 gram mass added. Show that the manufacturer will need us to select a spring with a spring constant of about 120 Newton meter. So you are given extension 0.8 and for each mass of 100 gram, and you need to figure out a spring constant. So you know that F is equal to Kx. This is Hooke's law, and in this case F, because this is a spring balance and you are hanging weight or masses, so F is in fact weight. So W is equal to Kx, and W is mg equal to Kx. So for 100 gram, 0.8 1 times 9.81 equal to, we need to find k, and x is 0.8 centimeter. That means it is 0.008. That means if you make k as a subject, so k is equal to 0.1 times 9.81 divided by 0.008. Remember, the 0.1 is the mass in kilogram, dividing by 1000, the 100 divided by 1000, so 0.1. If you solve this k, so you will have a k is equal to 122.6 Newton meter inverse. Part B, the manufacturer states that the maximum mass that can be hung on a spring balance is 1.2. Explain why it is necessary to state the maximum mass. Yes, of course, it is necessary to express the maximum mass, so the scale is considered a calibration, so no one should use mass greater than 1.2 kg. If someone use greater masses, it is possible that the spring is going to be permanently deformed. It will not return to original shape or original length. So that's how you can write the explanation. Thank you very much for this video. Have a nice time.